In the last lesson, we already finished studying about the infinite set approach. And today we will learn about feasible set approach. And we will go through two main models. The first one is costing model and the second one is scoring model. The feasible set approach identify the available sites, then we compare them and we find the best site. For example, we want to open a new branch in Ho Chi Minh City. Then we check and we see District 2, District 3, and District 5 are available for our store. So we compare District 2, District 3, and District 5 and see which one is the best. Then we will locate our new branch there. For costing model, we calculate the total cost from each location and then we find the cheapest. Do you still remember how many types of costs do we have? We have two types of costs, right? Fixed cost and variable cost. Okay. In costing model, we concentrate on variable cost, those costs that can vary, particularly the transport and the operating cost. So we have the total variable cost is equal to the operating cost plus the inward transport cost plus the outward transport cost of a facility. Do you still remember what is inward transport cost and what is outward transport cost? So from supplier, let's say you are manufacturer, so from supplier to manufacturer, that one is inward transport cost, and from manufacturer to customer, that is outward cost. And we already learned in the last lesson that if the location located near to the customer, we will have higher cost of inward transport cost. And for those near to supplier, we will have higher cost of outward transport. So we want to choose the best location. We want to compromise the location so that we can minimize the total cost. So the best location is likely to be somewhere in between the customer and the supplier. Okay? And we assume that the transport cost is proportional to the distance moved. We use the maps to we use the map reference or the coordinate to find the distance between the points between facilities. And we use the costing model to identify the location with the lowest total value of load multiply distance moved. So we compute the value of load times distance for each site. Then we choose the site with the lowest value of load multiply distance. And the distance can be the actual distance or the straight line. So we have two ways to measure the distance. The first way is the rectilinear distance and the second one is Euclidean. So for rectilinear distance, for example, we have 2 points that the coordinate is x1, y1 and the second point is x2, y2. So we calculate the distance between the first point and the second point by going to the straight line from here to here, then from here to here. That is rectilinear distance. So the rectilinear distance between the first point and the second point is equal to the absolute of x1 minus x2 plus the absolute of y1 minus y2. How about the Euclidean? Euclidean is we calculate the actual distance from first point to second point, from here to here. So we calculate the Euclidean distance by x1 minus x2. We take square, then plus y1 minus y2, take the square, and we take the square root of this sum. We will have the Euclidean distance here. Okay. So first we will see an example that use Euclidean distance to calculate the costing model. So we calculate the total value of load multiplied by distance. Load here is maybe weight or number of trips or number of units that shift from proposed site to the location I. And di is the distance between the proposed site and the location I, and we calculate the Euclidean distance by this formula. And we have x, y is the coordinate of proposed site, and xi, yi is the coordinate of existing facility. Now let's see this example. We have potential site. Three sites, site 1, 2, and 3 are potential sites. And here is the respectively coordinate of each site. And we have 4 suppliers, A, B, C, and D. And we also have the coordinate of each suppliers. And WT is the weight in each supplier. So here for the site 1, we calculate the Euclidean distance from supplier A to site 1 by xa minus x1, take the square, plus ya minus y1, take the square. Then we have the value is here should be we take the square root. Then we have the value is the distance is 161.2. So on and so forth. We can calculate the distance between site 1 to supplier A, site 1 to supplier C, site 1 to supplier B, and site 1 to supplier D. Then we take supplier, we multiply the distance A to site 1 with the weight, that is 161.2 times 75 plus the distance from supplier B times the distance from supplier B to site 1 times the weight of supply B, that is 412.3 times 105, and plus DC multiplied by WC plus DD times WD. So we can calculate the total value of distance times the load. And the same we can calculate for the site 2 and site 3. And after calculate the load distance value of 3 sites, we compare which potential site give us the lowest load distance. Then here we can see the site 3 gives us the lowest load distance value. So we choose site 3 to be our location, to be our new location. And here is another example that you use the rectilinear distance. So the same that we have 7, we have to serve 7 customer, and we have the coordinates of our 7 customers. And also we have the average weekly demands, the load of each customer. We have 3 alternative locations. It means we have 3 potential location and coordinate of 3 alternative location, and we want to determine which one is the best site among these 3. If the operating costs and inward transport costs are the same for each location. So here we don't consider the distance between supplier to our industry. Only we assume that the inward transport costs are the same. So we only consider the outward transport cost. So here we can see we have the location of 7 customer is here A, B, 1, 2, 3, 4, 5, 6, and 7. And here is our 3 potential location. And we want to see which one is the best one. We can calculate the here. So the site, okay, we have to calculate the distance between the customer 1. Let me calculate for the location A first. So we have to calculate the distance, the rectilinear distance of from the customer 1 to location A. So it's like this. We have to calculate from here to here and from here to here. That is equal to y1 minus ya, right? Absolute. Plus from here to here is x1 minus xa. Take the absolute. So here we have the distance, the rectilinear distance from the first customer to the location A is equal to 100 minus 120. Take the absolute. So we have 20 plus 110 minus 90. So it's also 20. So we have the rectilinear distance between the location A to the first customer is 40. So on and so forth. You can calculate the distance from the second customer to location A until say customer 7 to the location A. And the same, you also can calculate the distance from the first customer to location B and C. Okay, then here is the distance between site A to the customer A, and the column B is the load of each customer. So we can calculate the value load times distance. So it's equal to 20 times 40 and it's equal to 800. The same, we also can calculate the distance from customer 1 to site B, and we times with the weight, the load of the customer one. So it's 20 times 120. So we have the value of distance multiplied by load is equal to 2,400. And then we calculate the sum of all distance load value of each site. So we have the total value of site A is 8,580, phi B is this, and phi C is this one. Then we choose the site that gives us the lowest value distance load. That is site B, right? Site B gives us the smallest value. So B is the best location for us to choose. And another application of costing model is we can use costing model to find the best number of facilities. So as we can see here, this is, let's say this is supplier, this is customer. So if we only have one facility, a few facility, we can reduce the inward cost but increase the outward cost, right? If we only have a few facility. However, if we have more facility, the inward cost will be increased and the outward transport cost will decrease. So our question is, how many facilities should we settle so that we can minimize the total cost? We can use the costing model to solve this problem. So here, the number, we can see this figure is the relationship between the number of facility to the cost. So if the number of facility increase, the inward cost will increase. The operation cost also increase. However, the outward transport cost will decrease. So we have the total cost life is like this. So we can find this point is the point that occurs the smallest cost. So we can find the optimal number of facility that occurs the smallest cost. Okay, so now we will move to the scoring model. So what is the difference between costing model and scoring model? So scoring model emphasizes the factors that are important for location, but cannot easily be costed or quantified. So for costing model, we consider the inward transport cost or operation cost or outward transport cost, but those are easily costed, or it's a like number quantified, it's easy to quantify. However, there are some factors that we cannot measure it by number. So that's why we use the scoring model. So those factors that are important to the location decision but it's not easy to quantify, like the availability or skills and productivity of workforce, or the political stability, or economic strength and trends, or quality of life, like health, education, welfare, or culture, so on and so forth, or population trends, then the availability of sites and the development issues, or the ease of access and parking, or access to public transport. So now I will just go a quick overview about the important factors for scoring model. So when the decision maker want the facility near to the raw material, like their main purpose is the location that is near to the raw material, they have to consider the factor of the availability of a workforce with skills or labor relation and communicate attitudes, also the quality of infrastructure and the closeness of supplier and service, also the environment and quality of life for employees. And also we need to consider the factor about government policies toward the industry. But if our concern is customer, we want to locate or the facility nearer to the customer, we have to consider more on those factors that are population density or location of competitors and other service, also location of other attractions such as retail shop, vis- visi- visibility of site, or the convenience for passing traffic and public transport, so on and so forth. So based on your objective, you will focus on different factors. Not all the company consider the same factors, okay? So what you have to do when you do you use the scoring model, the first step you have to determine the relevant factors in decision, like what you focus more, what kind of factors you consider. And second, you give each factors the maximum possible score that shows its important. Usually from 0 to 100. You also can measure it from 0 to 10. It depends on you. And the weight, the score, and the weight of each factor. So how important is that factor compared to other factors? And normally it's from 0 to 1. And then you consider each location and give the actual score for each factors. And then in the next step, you add all the total weighted score that is equal to the size score times the factor weight for each location, and you find the highest score. And then the final step, you discuss the result and make the final decision. So for the costing model, we choose the smallest value, but for scoring model, we choose the highest value. Okay, now I give you an example so that you will understand more about the scoring model. The Samsung company considered 3 alternative sites for its new facility, and they consider 3 major factors. The first one is availability of skilled labor. The second one is availability of raw materials. And the last one is proximity to the firm's market. Then we already go through the first step that we determine what factors we want to consider. Then the second step, we will give score for 3 alternative sites. So we have site A, site B, and site 3. For availability of skilled labor, they give the site 1 70, site B 70, and site C 50. For the factor availability of raw material, site A is 60, site B 40, and site C 90. And the last one, they also give the score for each site. And then they weight each factor, like how important it is. So for the first factor, availability of skilled labor, they give the important level is 0.5. Then the second factor is 0.3, and the final factor is 0.2. And remember, you can put this one 0.6, then 0.2, then 0.2. It depends on what you need in your company. However, remember, for me, the total weight is always equal to 1. Okay, and then we have the weight. We go through the second step. We determine the weight and we determine the score for each site, for each factor. And then now we calculate the weighted score for each site by multiply the factor weight with the score. So we have the weighted score of the site A for the skilled labor factor is 35, and for raw material is 18. That is equal to 0.3 times 60, and the third factor is 14. Then the so on are the same. We can calculate the weighted score for each factor for site B and site C. Then the next step, we will calculate the total weighted score by sum all this column. Then we compare which side give us the highest score. And here we can see that site A gives us the highest weighted score. So site A is the best location for us. The electronic maps of road networks allow another approach to location, which is based on an actual road layouts. We call it the network models. So we can use network models to solve two main problems. The first one is single median problem, and the second one is covering problem. So what is single median problem? Let's see here. We have a network with a lot of facilities. So we try to find a location for the facilities so that we can minimize the cost from this facility to other facilities in order to minimize the total cost. So how we can conduct the single median way? How can we solve this problem? First, we have to find the matrix includes the shortest distance between different location, different facility, or different towns. And then we find the shortest average distance. Then we combine this distance with the load carried. In the next step, we multiply the distances by the demands at each location. Then we can get the matrix of weight distance. And we compare among those locations or among those towns. We find the lowest overall value. And the location that have the lowest overall value will be the single median. So let's look at this example. We have this company, Iron Goods, deliver goods to 8 towns. and the location and the demands are shown in the next slide. And he wants to find the location for a logistics center so that can minimize the average delivery time to this town. So where should he locate his logistics center? So here is the 8 house that he has to deliver the product to. Uh, the blue number is the demand. For example, in the town CP, the demand is 25. And the distance, the green color is the distance from one town to another town. For example, 22 is the distance between the town AL to CP. And 15 is the distance between the town AL to BE. Okay, so from AL to BE, okay, AL to BE, we can see the shortest way is 15, right? So the distance between AL to BE is 15. How about from AL? Let me change another color. AL to EN. So we have several ways to go from AL to EN, right? So we can see we can go from AL to BE, then BE to BI, then from BI to EN. It's follow the red way, the red line. So we have the distance is 15 plus 9 plus 7. So we have, if we follow the red way, we will have the distance is 31. We also can have another way to go to EN from AL, like AL from BE, then from BE go to CP, CP go to FR, then FR go to EN. Follow the green line. So the distance, if we go uh, this way, is 15 plus 8 plus 6 plus 6. So the total is 35. We also can go another way, that is the yellow way, from AL to CP, CP to FR, then FR to EN. And the total distance to go from AL to EN, follow the yellow line, is 22 plus 6 and plus 6. So we have 34. So on and so forth, we will find all the ways that we can go from AL to EN. And we compare, then we can see if we go follow the red way, the distance is the smallest, so 31. So we don't care about other distance, other value, we just care about the smallest value. So we assume that the distance from AL to EN is 31. So the same, you can find the distance from AL to FR or AL to BI or BE to GO, for example. So we will have the distance matrix with this. So here we can see from AL to AL is always to be 0, right? Then AL to BE is 15, the distance, the smallest distance. AL to CP is 22, AL to BI is 24. This one is the distance matrix. So if you want to check if it's correct or not, you can check this one, the cross line. So if it's uh, a distance matrix is correct when this one has to be 0, this line, or 0. And the column B is the weight or the load of that town, like how many sheep, how many trip, or how many products, how many units they have to deliver the products to AL. Is 10. Okay, then the next step, after we know the distance and the weight is the input, and the distance is you have to find by yourself the smallest distance. So we can calculate the weight distance value. So for AL, we will have uh, 0 times 10 plus 15 times 15, then 22 times 25, BI 24 times 20, so on and so forth, until HT 36 times 15. Then you take the sum of all the weight distance. So you can uh, calculate the value of the weight distance of a center at AL. Then you can see here. Here is the weight distance of a center at AL. Here is the total weight distance of a center at BE. So we compare those numbers and we can see that if we locate the facility, the logistics center in EN, it will occur the smallest value of the weight distance. So we choose EN to be the single median. Okay. How about the covering problem? So the covering problem, we locate the facilities that provide some service required by customers. For example, I want to open a restaurant uh, to serve the customer in an international university and University of Technology. I want to serve all the students or all the staff and lecturers in two university. So where should I locate my restaurant? Should I locate my restaurant in IU or in University of Technology or in somewhere in the between? So when I choose the location for my restaurant already, that one then I can solve the covering problem. And we can use the network model or covering problem. For covering problem, we can solve two types of covering problems. The first one is look for the single location that give the best service to all the towns or the customer. So go back with the example I told you earlier that locate a restaurant so that I can serve all the customer or the students or the people in IU and in University of Technology, so that I want to determine the location of the restaurant so that I can serve them in the shortest time. So for example, I here is IU, here is University of Technology. Let me say it's UT. Then somewhere in the between maybe the night market. So if I locate my restaurant in IU, the longest customer has to wait, the longest time the customer has to wait is 15 minutes. If I locate in University of Technology, the longest time that the customer has have to wait is 20 minutes. And if I locate my restaurant in the night market, the longest time that the customers have to wait is 10 minutes. So I will choose to locate my restaurant in the night market. So that is the first type that I look for the single location to give the best service. Best service here we consider the shortest time is 120, okay? And the second type is I find the number of facilities needed to achieve a level of service and their best locations. So okay, if I locate in the night market and the longest time that the customer have to wait is 10 minutes. However, the customer are very uncomfortable with waiting for 10 minutes. They want us to deliver in 5 minutes. So if we want to satisfy the customer that deliver the products, the lunch or dinner to them within 5 minutes, with one restaurant in the night market, can I do it? If I cannot, how many restaurants do I have to open? Maybe I have to open one in IU and another one in University of Technology, for example. So another type of covering problem is find the number of facilities needed so that they can achieve the level of service. So let's look at this example. We have a figure later that shows the travel time between two towns. Then the question is where would you locate a depot to give the best customer service? So the best customer service here measured by the delivery time. So it's equal to the shortest delivery time. And the second question is how many depots would be needed to give a maximum journey of 15 minutes. So let's look at the figure. We have how many? We have 10, 10 facilities. So the green color is the travel time between two facilities. For example, the travel time between A to B is 10 minutes. So the same as the single median problem, but here it's not distant. But here we measure it by the delivery time, the travel time. But the same that we have to find the smallest time to travel from one facility to another facility. For example, from A to C, we have uh, obviously two ways to go to C. That from A to B, then B to C, and from A to D and D to C. So we have the pink way and the yellow way. If we follow the pink line, the total time to travel from A to C is 10 plus 14 is equal to 24. If we follow the yellow line, the total time to travel from A to C is 10 plus 15 is equal to 25, right? So we will take the minimum travel time that is 24. So the same, we can calculate the time from travel time from A to G, A to E, A to F, so on and so forth. And we can make this matrix. So this matrix is similar to the distance matrix we made in the single median problem earlier. So we have from A to A is 0. From A to B, the minimum time to travel from A to B is 10 minutes, and the minimum time to travel from A to C is 24 minutes, and so on and so forth. You can fill this matrix. And then in each location, we will see how long is the longest time for the customer to wait. So if we locate the facilities in A, we can see that the maximum time the customer have to wait is 35 minutes. And if we locate our facility in B, the longest time the customer have to wait is 30 minutes. So on and so forth, you can determine what is the longest time the customer have to wait if you locate your facility in C, D to J. And then we will compare the maximum time the customer have to wait between different locations. So here we can see if we locate our facilities in C, the longest time that the customers have to wait is the smallest, that is 25 minutes. So we will choose C to be our single location so that we can cover all the customer in the smallest time. And we have the single location is C and the maximum time is 25 minutes. The second question is how many, if we locate at C, the maximum time is 20 minutes, but the customer one, the waiting time, the maximum waiting time is 15 minutes in place of 25 minutes. So to achieve the customer requirement that the maximum journey is 15 minutes, how many deports would be needed in this case? So we will just take the time that are less than 15 minutes. So for A, we will take this from if we locate in A, we can serve the customer in B because it's in 10 minutes. 24 no, because we want our, if we locate our facility in A, we cannot serve the customer in C within 15 minutes. But for D, we can. For E, F, G, H, I, J, we cannot because it's over 15 minutes. So we have 2 points. If we locate our facility in A, we can satisfy the customer in A, in B, and in D. If we locate our facility in B, we can satisfy the customer in A, in B, in C, in E, in F. Sorry, not in E and F because it's already over 15. So in G. So if we compare, if we locate our facility in two depots, that is A and B, we can satisfy the customer in A, B, C, D, and G, but we cannot satisfy the customer in E, F, H, I, and J. So that if we locate our facilities in two depots, that is A and B, we cannot satisfy the customer, we cannot serve the customer within 15 minutes. So it's not satisfy our requirement. However, if we put another facility in C, we can satisfy the customer in B, in C, in D, in E, in F, in G, and in I, and J. So we compare again. If B and C, we can satisfy customer from A, B, C, D, E, F, G, I, and J, but we cannot serve the customer if H within 15 minutes, so it's also not good. How about D? We can satisfy the customer in A, in C, in D, in H. So if we see from C to D, we can satisfy the customer in A, B, C, D, E, F, G, H, I, J. So if we put our location in C and D, we can satisfy the customer within 15 minutes, right? So on and so forth. We also uh, do the same thing for the rest of location. So we will have several options to put our location. For example, A and I are also okay, or C and D is also okay. So in the exam, I just require you uh, to help me choose one pair only. But if you can see several pair, you can list all out and tell me which one you prefer and the reason why. For example, here we have A and I also satisfy the requirement, and C and D also satisfy the requirement. So we can compare for C. If we locate the first facility in C, the maximum time the customer have to wait is 15, right? Because 14, 0, 15, 11, 5, 15, 11, 14. So the maximum is 15. For D, is also 15. So compare A and Y and C and D, which one is better? Of course, if we locate it in A and I, is better because the the longest time customer has to wait is only 10 and 15. But here, the longest time customer has to wait is 15 and 15. So here is better service. So you can choose. We should uh, locate two new depots, so that can serve all the customer in within 15 minutes, and two locations are I and A. Okay. So in general, how we can do a location planning. So we can follow 5 steps. The first one, we identify the features needed in a new location, and how you can identify those features. It depends on your company's strategies or your structure of supply chain and your purpose. And after identify the features needed in the new location, we look for the regions and the countries that can uh, best match with those features. And after that, within the identified region, first we look for regions and countries. Then within the identified region we find here, we use an infinite set approach, such as the center of gravity or similar model to to find the best area for locations. Then after you find the best area for locations, you search around this area to find a feasible set of available locations. And in the next step, you use the feasible set approach we learned before, such as a costing model or scoring model. Then you compare these alternatives. And finally, you discuss all available information and come to a decision where you should locate your new facilities. So a good location planning is you have to combine both our infinite set approach and feasible set approach. We also can use the following procedures. First one, we examine the overall aims. We, based on our logistics or our business strategy, we identify the aims and the goals of logistics in terms of like customer service or cost or timing. You want to minimize the cost, you want to minimize the delivery time, or you want to maximize the customer service. So based on your goal, your purpose, you will examine the overall aims. And in the next step, you will do the logistics audit. So you have the aim, the overall aims, and you see if your current supply chain, your current logistics network can satisfy all aims already, all those purpose already. So in the second step, you'll see the detail of current logistics system, like the location of facilities or the network connect those facilities, measure performance, and industry benchmarks. So you identify the mismatch between the current, what you have, and want what you want or what you expect. This one is what you expect. What you have. So in the third step, you will see if what you have match with your expectation or not. If not, if there is a gap between them, we have to find the alternatives to overcome this mismatch. So in the fourth step, we examine the alternatives to see where and how the structure of supply chain can be improved. Then after that, we will make the location decision. We use the appropriate models like network models or feasible approach or infinite infinite set approach to find the best location and the size of these facilities. Then after you make the location decision, you confirm the location to make sure that the location you choose in the step 5 is really the best and work with the structure identified in step 4. Okay, then after that, after you confirm, we implement and monitor the solutions. See if your local location, your solution is the best one. If it is, then it's perfect. But if it's not, if the location you made before is not the best location, you can do their again to their previous step, to the first step, and you do choose and make the location decision again until you find the best solution, the best location solution. Okay, so please help me distinguish the difference between the infinite set approach and feasible set approach. And in feasible set approach, we use the scoring models and costing model. What is the difference between them? Let me go back to the first slide. So here we have infinite and feasible. So in infinite set approach, we have the COG, the center of gravity, and in feasible set approach, we have the scoring model and costing model. So help me separate them, distinguish them when you use which approach. Then in network models, we use this one to solve the single median problem and the covering problem. In covering problems, we can solve we have two type of covering problem. The first one is we find a single location, and the second one is we determine how many uh, facility that they have to open so that they can satisfy their customer service. And the last part is how we make how we do their location planning. Okay.